Hello, in this video I will be explaining how we can use scripts to import the raw data from the RF survey to create usable statistics. To start, we'll use a template. This template contains all the scripting code that we will need to perform the first set of data analysis. First thing that we'll need to do is get the data. The data that we need is the raw survey data that is generated after each building survey. So first we'll go to the survey buildings, choose a building that we've already done, Old Hort for this example, and then under survey results we'll have a folder called raw data, and in that folder is the raw data. If we take a quick look here, you can see what the raw data actually looks like. So this is the way it comes to us after it's the scan is completed. So we have our grid and our area. So area is basically the cells within the grid. So the grid is kind of the master rectangle, and then the area would be the 4 or 6 cells or whatever you decided to break your building up into. So in this area here, and then this cell, the scanner will scan. These are the frequencies that the channels, I should say, that the scanner scans. So it scans all of these cellular. So that's 25 in total cellular, and then it also scans all of these Wi-Fi bands, which let's see, there's 28 Wi-Fi bands, and then one. This is the public safety MPSCS. So roughly we say about 60 channels in total that we scan, and it scans the channels. And this is basically, a lot of this is just kind of static data. It's just the frequency, it's just the metadata behind the channel. But here's where we start actually logging the measurements. So we have the download power, which we're not as usually interested in that, but the download signal power we are interested in, as well as some signal to noise. Depending on where you're at, it may or may not log signal to noise. Depends on how good the signal is. So those are the measurements that we're interested in here today. How can we look at these and analyze them a little closer? So what we'll want to do is go out and grab the raw data. So if we hit this Get Data button here, that will take us out and let us browse and pick out that data. But let's take a second here to see what's going on there. So behind that button here is a couple of subroutines. We go out, open the file, go grab the data, and then these are the rows. It's picking out those rows that I showed you: the download power, the signal and noise, and some other stuff. And then it's performing a few little fancy routines here to clean up the data. So that's what's going on behind the scenes. So once again, if we click the Get Data button, and then we'll have to browse to our folder that we just looked at, and let's choose, go ahead and look at Old Hort again. I think that'd be a decent building, and survey results, raw data, and then we want the one that says area test points. The reference points are points like the fiber room, or measurements from outside. So we don't want those for this particular thing, but those are useful data points to have, just not for what we're doing right here. So we've run that, and then it pulls in all the data here. So as you can see, it's populated and brought in our signal power and our signal and noise. And so these should look familiar from the raw data. All we've done is just brought in our 60 or so channels. So we got our cellular, and we got our Wi-Fi, and down here is our two-way radio. So that's all brought in. here into this column, and this is some and then I added some conditional formatting to give some sense of the quality of the signal. Your standard red to green type scales, and you have your signal to noise here, and this is the signal power. The next thing I wanted to do was create some kind of rating that would take into account both the download signal power and the signal to noise. Basically trying to say that if you have a good signal to noise, that's going to improve the overall signal quality. So the rating is just simply adds these two numbers together, and then from there comes up with a number that between 0 and 6, kind of like a signal bars, 0 to 4 bars or 5 bars, except in this case it's 6, but it's similar, with 6 being the highest and 0 being the lowest. So what I did is I came up with a case statement that said if you add these two numbers up and then it takes a look at the values, and so if it's greater than or equal to minus 65, then it's assigned a value of 6, which would be the highest, which is minus 65 is a good signal, and so on all the way down till you get to, if these two numbers add together and are lower than minus 60, then it's a value of 0. So to run that case statement, all we do is hit analyze data. So it fills in the rate column. Do that, and there you go. It applied that algorithm to all of these and comes up with a nice little rating here in this column. So the next thing we're interested in is we got to find out the best rating of all these. So we have 26 cellular signals. We have Verizon to some of them, Sprint to some of them, AT&T. So we want to figure out, well, which one, and there are different frequencies. So we need to figure out which Verizon channel was the best, because we have a few here. We have 1, 2, 3, 4, 5, 6 LTE Verizons, and then we have a couple CDMA Verizons up here as well. So which one of these 6 Verizon channels had the best signal? So that's what's going on over here. We have a little max if statement that goes through here. Let's see if we do this, you can see what it looks like. Yeah, so you have a max if statement. It's pulling what's in these columns, and it's checking against which one that says Verizon, and it says pull out the one with the best quality signal. And so that tells us right here that the best we had was a 4 rating signal. The level was minus 94, and the frequency was 751 megahertz. So that's all that's going on here. So this quickly pulls through and tells us which band had the best signal in this particular area. And this is just repeated all the way down. So for every cell within the grid, same thing. Just goes all the way down. And it also it doesn't do all that analysis for the Wi-Fi, but it does pull. So we did pull in Wi-Fi, and we have the kind of our typical channel 1, channel 6, channel 11. We always seem to have activity on those, and then some in the down here in the 5 gig range. So what it does do though is there isn't a little bit of analysis. It goes through there with a similar type of statements. Of this time it uses an index statement. But anyways, it tells us the Wi-Fi band 1. So at 2.4 we had the best signal at minus 45, and it also counted how many Wi-Fi access points that it measured. So basically, it's just a count statement through these four, and it finds, counts up how many were. So if it's minus 30, basically it's saying that there's no signal, and then like we can just assume that there's no access point operating in these frequencies. So there is a little bit of Wi-Fi analysis going on here as well. So what I did after that is I just took all the information in these columns and took it all over onto another workbook page, and it just kind of summarizes it, and this gives you actually a really better feel for the numbers. That I used the conventional formatting and gave a little bit of color to them and stuff. So this helps paint the picture in grid 1, area 1. So this particular building had a 2x2 grid, so there are 4 squares in it, and in each area of that grid, that's how it looked. So what might be helpful to understand that is, let me pull in the grid. So this is what the grid actually looked like for Old Hort, just to give it a little flavor. So grid 1, and then here's our little cells or areas in between. So you have area 1, area 2, area 3, and area 4, and that's being reflected in these stats over here. So you have your, like this. So you have your grid 1, area 1, so that would be what's going on here, and so on around. So each one of these blue circles is an indication of where we stood when we took the measurement in the building. So basically this point right here is all these levels right here that we recorded. So it takes into account also the MPSCS signal as well for public safety. And there's also a kind of a summary of the summary page here that pulls in, and so this is where we pull in the information for the final Word document report. It pulls from this, and then there's also Wi-Fi. It's basically just reporting in a spreadsheet type format the information we already looked at, but this will make it easier to give pass along to the Wi-Fi team. So next what we have is a running spreadsheet that tallies all the buildings up as we do them. So here's the buildings that have been done so far, and for example, here's Old Hort. So the Old Hort information has already been imported into this spreadsheet right here. Basically it's just taking this part of the data is just already data that we know. I've tacked on some kind of statistics about the square feet here, so you can get an idea how big the building was, what size the grid was, what size the cell was, and some other things. And then there's some stats here about each one of the carriers. That's what's going on over in this size. It's telling us that, let's see, for Old Hort, for Verizon, it's giving us the levels and the signal quality. So 100% of what we measured over there for Verizon was had good levels. So that goes a lot. So it looks like we only really had some trouble over here in the T-Mobile area. Had some problems, but there is some data importing. So if I were to want to to grab the raw data from Old Hort, we would just hit, or any building, we would just say get data, just like we did on the other ones. Find the building that we did. So let's see, we were just doing Old Hort, and then survey results, and then these are the spreadsheets for each one of the floors that we ran that initial RF analysis program on, and then we import it. This one takes a couple of seconds because it's actually doing more than just populating this page. It's doing some stuff on the other tables. As you can see, that popped in right there. And there's the stuff for Old Hort that you see it imported in. So actually, looking this over my data, I probably Old Hort wasn't the best example to use because I had updated those spreadsheets a little bit after I had to do some fine tweaking on this. So actually, let's do this again, and this time though we're going to do it for Manly Miles, which is this template was updated to work a little more efficiently with this summary spreadsheet. So let me show you this one. This one worked a lot better. And then the changes were applied, so moving forward past Manly Miles, they all work better in this format. So here you go. As you can see, it came right in. We'll start on the first page. It imported Manly Miles, so the two grids that we did over there for the. So you have to import each floor by itself. So this is only going to be for. Looks like we did the. Yep. So you see this floor one. So it brought in that data. It also brought in the MPSCS data. So that's all here. What we measured for the police and public safety, that got brought in, and we have the Wi-Fi data also was populated as well. And then the raw data is just some behind the scenes stuff that I've got going on for creating some charts later on in some newer versions. So that all pulls in as well. So it gives me raw data to work with for some other little things we're going to work on for. This spreadsheet as well has quite a bit going on scripting wise to pull all that data in. It also has to have some logic to be able to figure out where the last row is, so it knows automatically that the next line that I want to import is going to be the first empty line. So there's some logic in there to figure that out. And some other stuff that goes in here, but it's quite a bit of scripting that goes along to importing the data. And then finally, what I've done is I created a building summary tab so each one of these buildings I kind of take a look at and just do some quick evaluation. This is more for leadership, so we can tell them which buildings looked pretty good and which ones didn't look that good. I divided it up between Verizon's and then everybody else, because Verizon seems to be the carrier that we really care about most anyways, so that's why I gave them their own column. And so just for instance, so far in the 9 buildings that we've done, we've really only identified one building, which was radiology, that really had poor coverage, and so that would be a building that we would probably want to look at if somebody had some money for a DAS or do some improvements, or at a minimum do our network extenders. We have some what I would call kind of warning track buildings here. Not great signal coverage, maybe even some spots in the basement or garden level areas that had signal dropout, but for the most part they were pretty good. So I put those in the kind of the yellow category, kind of keep them on the radar, just so people are aware of this. Maybe that there is somebody that's important in Nesbeth or something, and they think it's worth doing some improvements. So then we'll want to look at it. So this is, like I said, this will kind of be for leadership at the end. They can look through these and kind of make their decisions based on what we're given. The same thing applies here for other carriers. We've had, like I said, a few issues, Comarts, IPF, and this would be like your Sprints, AT&Ts, and T-Mobiles. And no building was terrible except for radiology across all carriers. Let's see, there's a little more intuitive insights into this. if you look at this total, so this is a running total here. So basically, this counts every building that we've done. 8 buildings. This is the total amount of square footage that we've done. So if you take every building and add them all together, so we're over 500,000 square feet here, and we barely even got started. And it's telling us that Verizon is kind of leading the pack in that for almost 80% of the buildings 80% for Verizon of all the square footage has been between 6 and 3.5. So that's good, solid, undeniably good signal, good data. So for 15%, they were kind of in the mid-range, where it's still good to make phone calls. Their data might be a little slower. And then only 5% of the buildings were in the 0 to 2 rating. And so that's pretty good. We see Sprint. Then you can this kind of is a good way to kind of stack all the buildings up together. So you can see Sprint wasn't as good. In fact, there were 25% of the square footage that we went over for Sprint had low signal. AT&T is kind of neck and neck with Verizon. I expect Verizon to probably pull away at some point and be the best, but at this point they're fairly similar. And T-Mobile, they're similar. They always run a little behind the other guys, but definitely better than Sprint. So here's some good metrics, just quick elevator pitch kind of stuff, and a very quick summary of how we're doing. So this is kind of our pulse rate of the project right here on this page. It tells us how many buildings we've done, how many square footage, how's Verizon doing, how's the other people doing. So and then we're doing the same thing this is figure I can share this with the police. They'll be very interested in how these levels are looking. Wi-Fi, I figured I'll share this with the Wi-Fi team. Same thing, just running total of all the levels that we've pulled in, and then the raw data. So that's it. Thanks.